Okay, I kind of got cut off in a weird place last time, but I want to continue where we left off. So we have an interior, which is a point that lies in the interior of an angle. If it does not lie in the angle itself and it lies on a segment with endpoints that are on the sides of the angle. An exterior is a point in the exterior of an angle if it is neither on the angle nor in the interior of an angle. So this is exactly like what you guys are probably thinking. We have an angle here with we have one ray here, our vertex here. So we have one ray as a side, two rays as a side, our vertex right there. A point is on the interior if it's like right there. So M is on the interior, is interior. Okay? Now if I have point P right here, it's not on the interior, the exterior. P is exterior. So we're looking at this angle right here. It lies within it. It doesn't lie on the sides of it. And it lies with the segments with endpoints that are on the sides of the angle. So M is interior, P is exterior. Let's continue with our definition. So degrees. Degrees is a unit of measure. Used in measuring angles. Angles and arcs. We're only worried about this angle part today. An arc of a circle, okay, so we're only worried about this angle part today. Degrees is a unit of measure. That's what a protractor is in. You guys know a protractor is that little, kind of looks like this, has a dot here, line, and then it has all those little lines. That's a protractor. And we have 180 here and 0 here, and then 90 is right there, which we want to discuss what 90 is. A right angle is an angle with a degree measure of 90. Angle with a degree measure of 90. Okay? It is denoted by, if we draw, oftentimes you'll see it in the book with a little square like that. That means it is 90. The measure, this is angle A because I have my vertex here and I'm labeling it A. So the measure of angle A equals 90 degrees. Okay, an acute angle is an angle with a degree measure less than 90. Less than 90. So an acute angle is an example up there. So it's anywhere on this side of the 90. So let's draw our 90 so we can get a picture. And then we have our horizontal line going right there. Okay, and an acute angle is anywhere on the right side. So it's anywhere over here. If it's on this right side, we want it less than 90 degrees. We have our 90 degrees here. This is less than 90 degrees. Okay? And an obtuse angle is the opposite of an acute angle. So it is an angle with a degree measure greater than 90. So we have our little 90 degrees, right? It always helps to draw that. Then we have our horizontal ray and an obtuse angle angle is anywhere on this left side. So it's right here. This is our 90 degrees. This is obtuse. Okay, you guys are probably familiar with that. So then we need to go over here to angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. A ray that divides an angle into two congruent angles. Okay, so if I have, I'm going to actually draw this up here. So if I have my angle here, beautiful angle, right? I have my angle there, and my vertex is point P. One of my sides, one of my rays has a point Q in it. The other ray has a point R in it. My angle bisector is going to be right in the middle, as close to the middle as I can get. So this angle is congruent to this angle, okay? So we can put a W there. That's going to be our angle bisector. So ray PW, how do we denote a ray? The little line on top is a bisector of angle P. Is the bisector of, and this is how we draw angle P. We call angles by their vertex, so this is angle P. This would be whatever that vertex is. If I labeled this, this would be angle A. So I would draw a little angle A. That is how we denote them. The last thing I want to go through, I'm going to erase some of this top part, because you guys probably should have rays down. That was from our last lecture. So the next thing, and you guys should have angles down, so I'm erasing that, and sides, and vertex. So I do want to mention that so we have a plane. Imagine we have a plane. We have a beautiful little plane here. If I put any angle in here, I'm going to draw an obtuse angle. Remember, obtuse means that it's bigger than 90 degrees. This is larger than 90 degrees if my, okay? I put an obtuse angle in there. I'm going to put some points. P, Q, A, and then M and N, and we're going to put an S in here and an O. Okay. Oh, that's supposed to be an O. Sorry about that. Okay. So we have, what points lie on the angle? On the angle. We have point M, point A, and point N. M, A, and N. What points lie on the interior? Remember, that's on the inside, so the interior is this part right here. What points lie on the interior? We get points P, or point P, and point S, right? That's on that inside. Now we're going to talk about the points that lie on the exterior. The exterior is this green area right here. anywhere on the outside of that angle. So points exterior, the points exterior are point O and point Q, right? Point O and point Q. So what do we see from this? We see that an angle divides a plane, that's what I drew right there, that's a plane, into three distinct parts. What are those parts, you might ask? A is going to be on the angle. So that's one. I'm going to call this 1. So 1 is on the angle. Another part is on the inside of the angle, so the interior. And then 3 is exterior. Okay, I want to do a couple other things with this diagram. I want you to name the sides. So what are the sides of my angle? Sides of angle. What are my sides of the angle? The sides of the angle are the ray A, M, and the ray A, N. Make sure you do a ray with one arrow. That's how I know it's a ray. What's the vertex of this? The vertex is point A. What can we call this angle? We can name this as angle A. Everyone get that? Perfect. In the next video, you'll get more examples. Hopefully this gives you an idea of what a right angle, acute, obtuse, and all of the different parts of an angle and a plane is.